Today we're going to look at logic statements and how we can convert them into logic circuits. On the right hand side you can see I have a logic statement that I want to make into a logic circuit. But first of all we need to understand what the inputs are and what the outputs are. You generally find that the outputs are the latter end of the alphabet. So you can see here we've got an X, so that would be my output. It also starts the logic statement. The inputs are normally the beginning of the alphabet. So we've got an A, we've got a B, and we've got a C here. So they're going to be my inputs. So in my little editor, I've got an output on the right hand side. I'm just going to add a couple more inputs. So I've got A, B, and C. So now I've got my inputs and outputs in place, I've got to think about the gates to go in between. So if we have a look at our statement, we can see there's a number of brackets. What we normally do is work from the inside bracket outwards. So let's just have a look at the statement. We can see we've got a bracket here, well, a double bracket, because we've got a bracket and inside that bracket is another two brackets. So we're going to start by working from the inside brackets outwards. On the other side of the statement, we have another bracket. In between the brackets, we've got a NAND gate. So what I'm going to do to start with is just put that NAND gate next to the output because it's outside of the brackets. So I'm going to get a NAND and I'm going to position that next to the output. Okay, so I've got it here. Right, so let's get back to our statement and working from the inside brackets outwards. I'm going to go to the first inside bracket. We've got A is 1 and B is 1. So the gate we're going to use in this case is AND. So I'm going to add an AND to my statement, to my circuit. So I've got an AND in between A and B. So I'm going to link A and I'm going to link B. Okay, so far so good. Let's go to the other bracket inside this big bracket. So A is 0 and C is 1. Now straight away we notice that the A is 0 in this bracket whereas it was 1 in the last bracket. So how can we make the A be 1 and 0 at the same time? Hold that thought because we'll come back to that. At the moment what we're concerned with is what the gate is in this bracket, which is an AND. So I'm going to grab another AND gate. So this time we are linking A and C. So I'll just position this and grab an A wire and grab a C wire. Okay, right, notice now we've done the two inside brackets of this statement. We now need to look at anything else that's in the overall bracket here. Okay, we see an OR gate. The OR gate is linking these two smaller brackets. So let's grab an OR gate. Okay, so what I need to do now is link the first bracket, which is the A and B, and I need to link the second bracket, which is A and C. Okay, so far so good. Let's have a look at the last bracket. The last bracket is B is 1 and C is 0. Once again, you'll see that C is 0 here, but C is 1 in the other bracket. So how can C be 1 and 0 at the same time? Hold that thought, we'll come back to that. What's important at the moment is the gate that we see in this bracket, which is an AND gate. So I'm going to grab an AND gate, and this time I'm linking B and C. Okay. Right, so what I can do now is link this bracket, okay, that has an OR gate in it, to the NAND gate. And I can link this bracket, which has an AND gate in it, to the NAND gate. So let's just link them up. Okay. Now at the moment it's not going to work, because remember that we have in our statement A is 1 and A is 0 at the same time. Same again with C. C is 1, C is 0. So that's not going to work unless we add something to change that 1 to a 0. That would be a NOT gate. So I'm going to grab a NOT gate first, and if you have a look here, it is in the second bracket, which is the A is 0 and C is 1. So I have to find that AND gate first. So let's have a look. We've got A and C is here, so it's this middle one here. Now what I need to do to change the A in this case to a 0, I need to put that NAND gate, not a NAND gate, a NOT gate to this here. So I'm just going to get that wire and just put it through this NOT gate, this inverter. Okay, right, so far so good. Let's have a look at the other one. So same again with here. We've got C is 0, so B is 1 and C is 0, so I've got to look for that one. So I think that one was this one here. So B and C. So same again, I need a NOT gate, and I need to position it on the C. So I've got this, I'm changing the C to a 0. Okay. Right, so let's have a look again. Now, first of all, I had an A is 1 and B is 1. So that's this simple AND gate here. We link in A and B. And then I've got an A is 0 and C is 1. So A is 0 and C is 1. You notice we've put a NOT gate in there to turn the A to 0. And last but not least is B is 1 and C is 0. So this is this one, and we've got a B. Okay, so that's the B. And we've got the C. Now it's a 0 because it's got the NOT gate in. So what I need to do now is just see if this works. So if I turn them all on, turn them to 1, the output now is on. Okay, so that is how you turn a logic statement into a logic circuit.